Welcome to Homework Lib.
Hi, so over here we have 2 mole of a perfect gas, which has a Cv equal to 5 halves of R, and we're told that we are at a pressure equal to 111 kilopascals. We know that this gas is subjected to heating in a reversible way from an initial temperature of 277 Kelvin towards a final temperature of 356 Kelvin. We're asked to find the, first of all, final pressure. Next up, the internal energy, delta E or delta U, depending on the text that you're employing. In this case, I'm going to stick to the notation of your professor, delta E. Next up, we want to find Q. And finally, the work. We are also given the information that this is a process in which the volume is kept constant. So, first of all, let's start with our defining equations. In the case for a real gas, we know that PV is equal to nRT. We're following the real gas or ideal gas law. Sorry, the perfect gas or ideal gas law. The other equation that we're going to use is the change of internal energy is going to be equal to Q plus W. But in the case that the volume is kept constant, the value for W is equal to 0. So we have already one of the answers. W is equal to 0. Delta E is going to be equal to Q. And in this case, since we are dealing with an ideal gas and we are assuming that Cv is going to be kept constant at all temperatures, this corresponds to NCV delta T. So the change of internal energy would be 2 mole times 5 over 2, the gas constant, that is 8.314 joules per mole Kelvin. Mole and mole cancel out. 2 and 2 cancel out. Here we're multiplying. And finally, by the value for delta T. That is 356 Kelvin, my final temperature minus my initial temperature, which is 277 Kelvin. As you can see, Kelvin and Kelvin get to Kelvin and everything cancels out properly. So the final result will be in joules, and the change of internal energy is equal to 3284.03 joules. Now, with this, we know that the value for Q is exactly the same, 0.03 joules, and the value for W is going to be equal to 0. So the only thing that we have left is calculate the final pressure. So the final pressure, we can find it dividing the final pressure by the initial pressure. Why is that? Because if we apply ideal gas law, let me do the algebra over here, pressure is going to be equal to nRT divided by B. We know that the volume is going to be kept constant, so the final pressure is going to depend only on the final temperature, and the initial temperature is going to depend only on my initial temperature. What happens if I divide one by the other? Well, let's check it out. We do the division, and then N cancels out, R and R cancel out, volume and volume cancel out, and we end up with TF over TI. So, from this equation, what we're going to find is the following. That the final pressure is equal to my final temperature over initial temperature times my initial pressure. This is equal to final temperature, which is 356 Kelvin, over 277 Kelvin, times my initial pressure, which was 111 kilopascals. Kelvin and Kelvin cancel out. The result will be in kilopascal and is 142.657 kilopascals. And this would be all. Just to recap, the answers would be delta E, Q, W, and final pressure. Thank you very much and have a good one.